We now have another quadrilateral proof, starting off with the fact that we have a rhombus given to us. Then two angles in this figure are congruent to each other. We're missing a reason and its statement. So let's take a look at the big picture. We have two opposite angles of the rhombus that are congruent. We have two congruent angles that are subtracted from these. We have the large angle, the two smaller congruent triangles, which results in these two angles being congruent. We have a pair of vertical angles here at vertex D, and then because the object is a rhombus, we have these two segments congruent to each other. Our missing statement, and then these two segments here, ED and FD, are congruent. We've seen this one before, where we have corresponding parts of congruent triangles congruent. We have to have congruent triangles. There's no statement about congruent triangles. So that's a dead giveaway that we need to show two triangles are congruent. What two triangles are they? Well, they're the triangles that include these two corresponding parts. So one of them is going to be ADE. Type that in there. And the other one will be CDF. I do need to put those in the correct order so that I have the corresponding parts identified. Now we need to come up with a reason. Why are these two triangles congruent? Let's go back and see. The previous line had two segments congruent. Prior to that, two angles congruent. Prior to that, two more angles. So we've got two angles and a side. Is it going to be angle, side, angle, or angle, angle, side? Look at where your angles are and look at where the side is. The side is in between or included between these two angles. Therefore, our reason is angle, side, angle. And we're complete.